Hi, I am Nazain Mohammadi from Curtin University. I'm going to show you Chapter 4 lab of CCNA Security version 1.2. In this lab, you are going to make a multi-router network and configure routers and hosts. Then we're going to use the CCP tools to configure the zone-based policy firewall on the routers. As you can see, the topology of this lab is exactly the same as lab 2 and 3, so connected devices the same way that we did in previous labs. Then we start to do the basic setting configuration, starting on R1 host name, interfaces, and then the clock rate and password recovery. So all this basic configuration that we need to do on the routers. Except for this lab, we're not going to use the static route. Instead, we are going to use a routing protocol called OSPF. Okay, so in R1, we are going to configure router OSPF 1, and we need to specify the network connected to the router. So this is the LAN network connected to router 1 and the WAN network. Then we do exactly the same configuration for router 2, the basic configuration. Then we specify the network for OSPF on router 2. The network connected to router 2 are 10.1.1.0 and 10.2.2.0. So we specify those networks. But the rest of the configuration was similar to what we did to router 1. I just omitted that part. And they are all in the same area, so when they advertise the addresses, they can get connected to each other. Now we do it on router 3. So this is the OSPF configuration on router 3. First starting with the LAN network. We use the network address and the wildcard mask for OSPF configuration. Then we specify the WAN network, so the network address and the wildcard mask and the area of the OSPF. Okay, now we specify the IP addresses on the PC. I just show PC1 on this one, or PCA, sorry. And then the similar procedure is going to take place for PCC, but it's just different address. To verify the IP address on PCA, we use the ipconfig command on CMD or command line. Then we ping R3 from R1. Then we ping PCC from PCA to make sure that there is a connectivity between the two LANs. So with the result of all these ping commands, the connectivity in our network is verified. Now we go back to router 1, finish off the configuration, the basic configuration. Security password minimum length 10, and then we configure basic console auxiliary port and VTY line on all the routers. We just show the router 1 configuration, but we need to do all these steps for router 2 and router 3 as well. Then we need to enable HTTP server. Enabling the services HTTP server and HTTP secure server let us manage the router using the GUI and a web browser. Then we encrypt the clear text password with service password encryption. So if we do the show run, we shouldn't be able to see the auxiliary console and VTY passwords in a clear text. So it's all encrypted. We repeat this procedure for router 2 and 3. And then we do the backup for all the routers, copy running config to a startup config. Nmap is an open source utility that is used for exploration or network auditing. ZenMap is a Nmap with a graphical user interface. So we use ZenMap. The Nmap and ZenMap is already installed on PCA and PCC, so you don't need to install it. Jump into step 2. We open the ZenMap, put the IP address on PCA and put the IP address of the router 1. And we do the instant scan. We run the scan and wait to see the open ports. It will take a while to scan all the ports and find the open ports. There are different stuff that it can be scanned with Nmap, like operating system. Sometimes it is not able to detect the correct operating system. So if you click on the services button, you can see the running services on router 1. We have HTTP telnet. In Nmap output, you can see the MAC address of R1, for example, and the operating system that ZenMap is detected for R1. Now from PCC, we open the ZenMap and we do the instant scan on the serial interface of R1 to check the outbound traffic. Now if we click on the services button, we can see the running services on serial interface of the router 1. Based on the router configuration, you get different services here. For example, we get HTTP, Telnet, and SSH on our router. You can see the distance or the hops between PCC and R1 by clicking on the trace route and counting the hops.